Hey guys, my name is Ethan, this is Carberra, and welcome to Series where I teach you how to analyze and visualize data in Python. Today we are going back to episode 9 a little bit, and we're continuing on with the box plot. So I showed you an example in episode 9 to compare Matplotlib and Seaborn, but in this video I'm actually going to be showing you how they work, and we're going to be showing you different types. So there'll be an enhanced box plot and a violin plot, and we'll be doing all the extra stuff like splitting them and, you know, there's a lot you can do with box plots, so I'm going to be showing you kind of a summary of the more important things. Of course, if you find this video helpful at any point, then consider liking to let me know and subscribing so you don't miss out on future videos in the series. But yeah, with that out of the way, let's get into it. So there's quite a lot more to talk about with the setup for this one. So we've gone back to our second half of 2020 data like we did in episode 10, I believe. But you'll see that we've actually inserted a new column called month next to day. If you are just using these data sets as they are, then you can just copy this in and it will give you the month that the record happened in. We're just using that to make some of the box plots a little bit nicer. We're also creating a second box plot once again, but this time we're using df copy, and we're actually changing the card teaser click rate column to say whether or not the number of clicks was greater than 0 or not. That's going to be useful for some of the stuff that we want to do. Essentially, there wasn't really an ideal data set for this one, so we're just using this. So if we make a new, if we run them all, you go load them all up. Actually, I might as well try and show you the, if I can. There we go. Card teaser click rate. Where is that? Is that one of these columns in here? Okay, never mind. Apparently, I'm not showing you that at all. So let's see. I can probably show you df2, and then if I just copy and then paste that in there, I can at least show you what this card is. Yeah, so it's true, false, true, false, or whatever. So that just gives us a nice Boolean thing to work with. So the first thing we're going to do is we're actually going to be using that. So fig equals plt.figure. And then to do a box plot, you just do SNS dot box plot. Those of you who just saw episode 9 will recognize this. And we're going to use data equals df2. We're going to do x equals month, and then y equals views. And we're not going to use the card teaser just yet. We're going to show you what this outputs first. So this just outputs a series of boxes. So you have months 7 through 12. That is July through December, respectively. I hope that's correct. I'm pretty sure that's fine. But as you can see, this kind of shows the same thing that the line and the scatter graphs were doing. So there was this leap in view, quite a substantial one, especially between August and September, where the entire box is lifted up. Although the upper whiskers are actually quite far away. These little dots here at the top of October and November are outliers. So these whiskers don't account for the whole data, they only account for a bit of it. But if there's anything that's like particularly higher than the rest of the data for whatever reason, it actually gets put in a diamond as an outlier, and it happens at the bottom as well. This line in the middle is the mean line. This is where the average, it's the median line maybe, I don't actually remember. But this is kind of where the average of the data is. So as you can see, the average of the data is quite low on this one. It's relatively high on this one. With the hue, it allows us to put two box plots next to each other per tick. So we can do hue equals card teaser click rate. This is basically the same thing we were doing before in episode, was it 10? Let me just load this one back up. Yeah, we were doing df just like greater than 0. We're essentially just doing that. We're just doing it a slightly different way to show you that you can do this. And as you can see, all the data looks different. So there's blue and orange ones per tick, and the outliers are actually quite a bit there. So there's not really any sort of correlation between higher card teaser click rates and higher views. But I'm doing this more to show you just kind of what it would look like and how you could separate them out. If they were more than just true or false, then you could, of course, have like 3 or 4 next to each other all in one go. But yeah. So the next thing I want to show you is a swarm plot and then also a strip plot. So these are really useful for kind of showing the data distribution within a box. So we'll do fig equals plt.figure once again. You should be very used to doing that now. No, we don't want to do a box plot. That's later in the video. You're spoiling it autocomplete. We're going to have x equals month, and we're going to have y equals views. We're not going to have any sort of hue, so you can just use the standard df for this. We're also going to put sns.swarm plot data equals df, x equals month, y equals views. Oh, that'd be y. That's going wrong. Y equals views, and then we're going to set the color equals 0.25 just to make things a bit easier to look at. And we're going to have fig.show. And that's going to error. Why are you erroring? I could not generate a palette for a map object. Oh, right. This needs to be a string for some reason. I don't know why, but that, yeah, okay. So this color, even though it's a number, it needs to be a string. I believe you could just pass in like blue or green in there. I don't know. Matplotlib is weird. But you see, we have these extra dots in here now, and this is basically where the data is. So it's sort of like a scatter plot for individual boxes. But what it's doing is it's plotting data down the middle line, but where there's more data where it can't quite fit, it will put it next to it. So essentially a swarm plot is a scatter plot where none of the points are allowed to overlap, which is why, you know, data spreads out to the side. On its own, a swarm plot isn't especially useful. You might as well just have a scatter plot. But for something like a box plot, it is actually very useful because it's not just a mess. It kind of shows you the actual distribution of the data. So for example, with the green one, you can see the the mean line is so low because you have this huge clump of data here, but then the upper line of the box is so high because there's another clump of data up here. You see that for November and December, the data was actually just quite well spread out across the board. And you know, in August it's low in the high again, and in July it was quite spread. So this gives you a far better idea of the actual distribution of the data. I generally don't actually make any box plots without putting a swarm plot on it as well. But if you don't like swarm plots for whatever reason, and you do have another option in strip plots. So we're actually going to just copy paste all of this and we're going to put it into another graph like this. But instead of a swarm plot, sorry if you can hear that, someone's being quite loud outside. I don't know what's going on. Instead of doing a swarm plot, we're going to do a strip plot. And it's exactly the same. But it just looks a little bit different. So in my opinion, it's not as good because this strip plot is really just a scatter plot for categorical plots, like a box plot. So as you can see, the main difference is that the data doesn't spread out to the side like it does. It spreads out to the side a bit, which is weird. I don't really know why it bothers doing that. But it doesn't spread out to the side as much as a swarm plot. I personally prefer the swarm plot because it spreads out to the sides to show the distribution better. But I guess if you had like some particular colors, then you could kind of map the clumps a little bit easier with the strip plot. I don't really know. But I generally prefer the swarm plot over the strip plot personally, although of course it is ultimately your decision. These are your graphs. So I thought I'd show you both nonetheless. So next one I want to show you is like a box plot, but a slightly different shape. And these things look kind of weird. And it's called a violin plot. Oh, violin plot. And you'll see why it's called that in just a second. Y equals views. We actually want to use df2 for this one because we are going to be doing a hue in a bit, no, not dfw, df2. And then we're just going to leave it like that for now. And we're going to do fig.show. And the reason it's called a violin plot is because these things look quite a lot like violins. So if we come back to our swarm plot, again, we can see that they, with these ones there are quite large distributions on the bottom compared to the top. And that is actually reflected in the violin plot because it's essentially a box plot, and a k-density plot all in one. You have your median line here as a dot, and then you have, I believe, the actual box is the dark bit. I could be wrong. Yes, that does appear to be it. And then these top and bottom lines are the whiskers where you'd normally get them. So yeah, it is essentially just a box density plot. They are very pretty. They're very weird to look at, but I don't know. I find them quite aesthetically pleasing, honestly. In a strange way, they're not quite as informative as a box and swarm, but they are just really nice. To be fair. However, as I said before, they can get a bit weird if you do certain stuff with them, especially if you use the hue. So we can have the hue once again as a card teaser. Okay, I'm just going to copy paste this because I don't particularly feel like typing it out. And the autocorrect doesn't work in Jupyter Notebooks for some reason. You can have the plots next to each other the same as you did. We can also have split equals true. And what this will do is it will create this absolute monstrosity of data. So what it's doing, hang on, if I take this away and actually bring up a separate graph in the plots so we can compare them. So you can see here, this one is a bit more bulged, and this one's a bit taller and a bit thinner. Well, this is actually shown in here. We have the more of the bulge here, and on this side we have the tall and thin. So instead of showing the two separate graphs side by side, it's actually showing the densities for each, like literally side by side, I suppose. The only downside of this is that you actually lose some of the data in the middle. So I think this is taken from. Let's see if we can work out for number 10. It should be quite easy. So it appears to be taken from. Yeah, it appears to be taken from the blue one. I think. I'm actually not sure. Or maybe I don't know. Maybe it's an average of the two because it doesn't appear to be quite similar to either of them. But yeah, this looks really quite odd as a graph. It's really rather entertaining, but it is kind of strange. So there is one more box plot you can do, and this is called a box and plot, but it actually just means an enhanced box plot. So we're going to have figure here once again, and we're going to do box end plot. So basically a box enhanced plot or an enhanced box plot. And we're going to do data equals df2, and we're going to have card teaser click rate. Oopsie daisies. And we're going to have y equals views. So a slightly different box plot we're doing here, just to mix things up. If we show that, we can see that we end up with this craziness. So if I just do it as a standard box plot for a second, we'll see that we just have these huge boxes here, and then we have the lines, and then we have the whiskers. With a box end plot, we have a bit more data. So these boxes are still quite big, but we also have extra boxes that kind of contain a little bit more information. So I'm just going to keep switching back. So this top one up here at 1600, this is now the top of the outliers. So the outliers are measured a bit differently on a box and plot, but essentially you have the same boxes, but whereas a standard box, this may contain the 25 to 75% range, and then this smaller box may contain like the 90 to 10 or the 10 to 90%, and this might contain like the 5 to 95%. You have I don't know the exact numbers off by heart, but then you have the outliers up here. So there are certainly better applications to a box and plot than this. This is kind of the best I can come up with. It's really not an astounding box and plot. I might actually show you a better one that I made for a separate project. I'll put that on screen now so you can kind of see how these box and plots can look, and how they can look really quite strange. They kind of look a bit telescopic, as how a telescope kind of extends out of itself. These look quite telescopic in that sense. which I quite like about them. But yeah, sometimes you don't really need them. Like in this case, you'd probably be able to get away with just a box or a violin. But in other instances, having a box and plot is actually quite useful. So you can just mess around with them and see what you come out with. But yeah, that's all I really wanted to say about box plots. There is quite a lot you can do in Seaborn, as I've shown. But yeah, if you have any questions about any of it, then don't be scared to leave a comment down below. Or you can join the Discord server using the link in the description. But yeah, with that, I'd like to thank my patrons for being as amazing as they are. And I'll see you next time when we talk about point, bar, and count plots / graphs.